Kenny's Components specialize in the design, engineering, production, as well as carbon fiber body repair and custom fabrication to meet exact specifications and needs. They use advanced composites such as carbon fiber, Kevlar, and fiberglass. The purpose of this project is for us to design a safer way to mount a 90-degree racing seat. Kenny from Kenny's Components got this idea when his friend Kevin Swindell, who's an American race car driver, experienced a very bad sprint car crash. This crash resulted in him being paralyzed below the waist. The project requirements for this project are: the seat mounting system must work in a sprint car, midget, and silver crown capable cars where the driver sits at 9 degrees. The forces must be distributed before they affect the driver. The overall dimensions of the chassis cannot be modified. The seat of the race car cannot be raised or lowered. The overall cost must remain within budget. After doing research and calculations, it was found that Kevin Swindell experienced approximately 20 Gs of deceleration during impact, of a time of 0.04 seconds. And at 20 Gs, a driver experiences a force equal to 20 times his or her body weight, which can cause severe injury like it did Kevin's. 14 Gs is approximately the threshold where injury to a spine can occur, and the ejection seats aim for 12 to 15, so that is our goal. After the research and calculations were finalized, it was determined that we could only deflect an inch. With that conclusion, many designs were gone through and looked at closely. However, with the help of a decision matrix, the split pin design came out on top. This design has one vertically mounted donut with 2 half pins. One half pin is from the chassis, and the other half pin is bolted to the seat. There is one polyurethane donut that holds the 2 half pins together. After the cow drawings were finalized, the machining and manufacturing began. The pins were machined first and then welded to the cups, which was welded to the chassis after the seat was mocked up and drilled. The chassis was then painted black and green, and one accelerometer was mounted on the seat and the other was mounted on the frame. During testing, 3 50-pound bags of sand were strapped to the seat. The chassis was dropped using a quick release hook, and it was dropped using 2 different durometers, 60A and 80A, and the chassis was dropped at 3 different heights for each durometer. With the help of accelerometers and a high-speed camera, the results showed that indeed our design worked. The 80A durometer gave the best results. The seat experienced at least 1 G less than the chassis in every test. Thank you.